All right, there's Science Faithful, video number 3. We're on page 6. It's called Insolation and Greenhouse Effect. It's good for that you should know that insolation is like incoming solar radiation. Insolation. Cute little thing, right? You just need to know what's going on. So, some energy is refracted by the atmosphere and the ozone. And in that refraction, it's almost it's not reflected, it's refracted, so it's allowed to pass through. Some energy is reflected by the atmosphere. It says about 5% backscatter to atmosphere, 20% reflected from the clouds. That's what the picture shows. So about 30% is lost back to the space due to reflection and scattering. Okay. Then some energy is absorbed by the atmosphere, clouds, land. Okay. So that's what's going on. In the first section by the picture, you need to get all that written in there. And then there's this piece. There's this little picture in there. So according to the graph below, what wavelength of energy has the greatest intensity? Well, this is visible light spectrum in the middle. We have long waves on this side, short waves on this side, and here is where the sun waves are. Okay. Greatest intensity is definitely going to be shortest wavelength as far as gamma rays is going to go right through everything and hit the earth and just bombard it constantly with gamma rays. Okay. So the primary gas that absorbs UV is ozone. So next to ozone, you're writing this. And we're going to get into the greenhouse gases. This is Aurora Borealis. That's the northern lights. And yes, the ozone layer is breaking down. So here's a picture of where the whole of the ozone layer is. I hear it's been shrinking. And why is it important? Well, these are some side notes you need to put in for ozone. It protects the Earth from UV. It's not a lot of room to write all this. Okay. But ozone is O3. It protects the Earth from the UV from the sun, which damages crops and causes cancer in humans. Okay. The next 3 primary gases. So these are the greenhouse gases. CO2. We get CO2 by burning of fossil fuels. Okay, so you need to write that. And you do need to write that, right next to greenhouse gases, they absorb infrared energy. You do need to write that, of course, much like a blanket would. And then methane. Methane comes from decomposition of garbage for sure. That's why in landfills there's those pipes. And cows are a source of methane. Harvesting, like natural gas, if you're going for any of the fossil fuels, there's a lot of methane production there also, probably more than from cows, just saying. And then water vapor is one of the 3 gases. So you got to get those 3 in there somewhere so you know what are the 3 primary gases. And then now we're going to get into the actual greenhouse effect. Okay, it says, why is it warmer on a cloudy night than on a clear night? Well, because the water vapor is going to absorb the infrared radiation. On a clear night, it's going to escape back into space. So it's going to come down through, bounce back up, and that's when the clouds start absorbing it and like keep it there. And then on a clear night, it's allowed to escape and it doesn't get quite as hot. Okay. So here's what's happening in the greenhouse effect itself. The sun rays come in. Shortwave UV energy. Definitely need to write this part underneath the greenhouse effect. UV energy goes through the glass, but then it's absorbed and re-radiated as long-wave infrared energy. In other words, the heat gets trapped inside the actual greenhouse. That's why it gets so warm in there. The infrared energy cannot go back out through the glass, so hence the temperature increases. A lot going on in here. But this is what happens in the Earth now. except for the sun comes down, hits the water or the land, and when it comes back up, the clouds trap it. Okay, so the clouds will act like the glass roof of a greenhouse. That's why we call it the greenhouse effect. Okay, and here's a good picture of that, where you can see the sun's energy hitting the earth and then it bouncing back on the atmosphere all the way around and slowly heating, much like it bounces around inside the actual greenhouse. Okay. So just like a greenhouse, the gases in the atmosphere, especially carbon dioxide, will absorb and re-radiated infrared energy. So it's somehow we need to make sure we take some sort of notes that make it so we can understand that. Okay. But that does not go into global warming yet. Global warming is coming. Global warming is the result. So here's a nice picture graphic of the cyclic change in the temperature. Average global temperatures are increasing. Glaciers are melting and the sea level is rising. That is happening right now. You can write all this stuff down. Warming is natural and cyclic, but there's a caveat there. But humans speed up the process by burning fossil fuels, deforestation, and pollution. So these are the pieces you need to get written at the bottom of page 6. And we'll call that a video. And then we'll do the next video separate, temperature and heat, because it's a different topic altogether. All right.